According to both Newtonian physics and our everyday experiences, time is absolute. Everyone experiences it to pass at the same rate. So if I were to take a run around the rugby pitch and measure how long it took me according to a watch I was wearing, and you measured how long it took me to run around a pitch wearing a watch as you stood still, we would measure the same amount of time to have passed, right? Well, it turns out that that's not actually true. If we had both been wearing atomic watches, atomic clocks, then we would have measured a different amount of time to have passed. How is this possible? Everything in our lives, every experience, time seems to pass at the same rate. Well, according to Einstein, something called time dilation occurs depending on one's state of motion. So, since I was running, I would have measured less time to have passed than you would have standing still. But this doesn't make sense. How can we test this in our everyday lives? Atomic clocks are not readily available. Well, some experimental evidence that exists to prove time dilation is in fact real is achieved using muons. And muons are these really small particles that are created in Earth's upper atmosphere, approximately 60 kilometers above Earth's surface. And muons, they decay really quickly. That means that they break up into even tinier particles after a really short period of time. And the period of time that we on Earth would measure it takes a muon to travel from the upper atmosphere down to Earth at nearly the speed of light is longer than we measure the lifespan of a muon to be. However, we have muon detectors here on Earth that measure muons are actually arriving on Earth's surface, and this seems impossible, right? I mean, how could it be that a particle would decay into tinier particles before reaching Earth's surface, according to our watches, yet we still have these whole particles reaching Earth? Well, if we use Einstein's concept of time dilation and the idea that a particle in motion is measuring time at a different rate, then it makes sense that we have these particles reaching Earth. Because if we see the muons as tiny clocks, and they are measuring time to be passing at a slower rate than we are here on Earth because they're moving at such a high speed, close to the speed of light. So, if we accept Einstein's theory of special relativity and time dilation, then we have an explanation for why we are having muons reach Earth's surface.